Continuing 10.2, Cyclone Development and Movement. As mentioned, tropical cyclones usually begin as a tropical disturbance, forming into a tropical depression, then developing into a tropical storm, and then intensifying into a hurricane. Right. We just discussed the formation of a tropical disturbance. As a tropical disturbance forms into a tropical depression, wind speeds increase and begins to spin, and a low-pressure center is formed. The pictures below are of two different tropical depressions. You can see the beginning of the formation of the characteristic spiraling clouds we associate with hurricanes and typhoons. Tropical depressions turn into tropical storms when winds increase to 63 kilometers per hour or 39 miles per hour. The storm is given a name. Note that though the wind speeds are not at hurricane strength, the rainfall can be intense. The series of pictures are of Tropical Storm Bertha and Hurricane Bertha. The figures go on the top left, July 4th, Tropical Storm Bertha. On the top right, July 7, Hurricane Bertha, Category 1. Intensifying to Category 3 on the bottom left, July 9. Hurricane Bertha, Category 2 is on July 14. Tropical Storm, and on July 14, Tropical Storm Bertha. The overlaying colors are rain rate in millimeters per hour. Is there much difference between the rain rate and rain coverage area between the tropical storm and the hurricane? Hurricanes and typhoons. Not all tropical storms develop into hurricanes. The tropical storms become hurricanes when the winds reach 119 kilometers or 74 miles per hour. Environmental conditions must be favorable, such as warm ocean waters at least 26 degrees Celsius or about 80 degrees Fahrenheit, must extend down to a depth of at least 46 meters or about 150 feet. This provides the energy for the storm. In addition, the atmosphere has a steep vertical temperature gradient with warm air near the surface and cool air aloft, which will cause the warm air to want to rise and keep on rising. And finally, there must be weak vertical wind shear. Strong winds aloft prevent hurricane development. There are several features of a hurricane. The average diameter, 310 miles, though the interior with high winds of at least 74 miles per hour are only found in the center 100 miles. The outer areas only have gale force winds, meaning greater than 30 miles per hour. Rain bands form in clouds that spiral inward around the center and increase in intensity towards the center of the hurricane. In the weather map of Hurricane Andrew, depicted to the right, the overlaying colors represent intensity of rainfall, with red being the most intense and blue being the least intense. Where is the most intense rainfall? Is it a gradual decrease in rain intensity from the center outwards, or is there a pattern of bands? Notice the donut of intense rainfall right in the center. That has a particular name. The name is the eye wall. It is the innermost band of clouds and contains the greatest winds and rainfall. Rainfall can be as intense as 10 inches per hour. For comparison, in Boise, Idaho, we get about 16 inches of rain per year. The left two images are of the eye wall, taken from within the eye of the hurricane. The right image is an annotated is annotated to point out several features. The large dark black arrows show the inwardly spiraling clouds. Is this in the northern or southern hemisphere? Get it? Northern. Then the image also shows spiral rain band and rain-free area. Also pointed out are the eye wall and the eye. The eye is an area of calm at the center of the hurricane, 3 to 37 miles in diameter. Fairly small compared to the whole hurricane. It is narrow at the surface and wider at the top. Interestingly, lots of birds pick this place to rest. I would think other animals and people would also find it much more relaxing in the eye than in the eye wall, or elsewhere in the hurricane. I bet it would be almost eerie in the calm eye. The pictures are of a hurricane eye as seen from the space shuttle, top, and bottom, the hurricane eye wall as seen from an aircraft flying inside the eye. Hot towers are another feature of hurricanes. They are tall clouds up to 7 miles high and develop within the eye wall 6 hours before the storm intensifies. The image on the top right shows hot towers that formed in Hurricane Katrina shortly before it became a Category 5 hurricane. I believe the colors overlaid on the image indicate temperature, with red being warmer than yellow. The cartoon below shows a bit of the air circulation pattern associated with hot towers and their relative height. Much higher than the Empire State Building. The hot towers help circulate the air faster, causing an intensification of wind. It also moves warm, moist air quickly into the cooler air aloft, causing condensation, releasing that latent heat, which makes the towers so hot, and also feeds the hurricane even more energy. No wonder they occur prior to a hurricane, increasing in intensity. Continuing with hurricane structure. Warm, moist air spirals upward around the eye wall. As air rises, it loses moisture as clouds form. Upward rotation draws air from the eye, causing dry air to sink back into the center. That's why there are few to no clouds in the eye itself. The upward rotation of air in the eye wall and the rain bands also causes air to flow out the top of the storm concentrated in exhaust jets, which allows additional warm, moist air to feed the bottom of the storm. The general circulation pattern is depicted in the cartoon. The red arrows represent the flow of warm, moist air from the surface, and the blue arrows represent the flow of cool, dry air from aloft, sinking down. There are additional blue arrows showing surface convergence of air. While the hurricane is still growing, it is being fed by warm, moist air over very warm ocean water. However, when the air at the surface is cooler and drier, perhaps as it goes over land or cooler ocean water, the hurricane begins to dissipate. Hurricane paths and demise. Movement is controlled by the Coriolis effect and steering winds. In the northern hemisphere, storms deflect to the right. Trade winds also help out, typically causing hurricanes to track west and curve northwest and then northeast. In the North Atlantic, hurricanes are also steered by the Bermuda-Azores high pressure. Hurricanes can even make a loop. They typically have a forward speed of 12 to 17 miles per hour, which can seem agonizingly slow if you are in the storm. As hurricanes move over land, They lose energy as they are cut off from the energy obtained from evaporation and condensation of warm seawater. The figure below proudly shows the tracks and intensity of all tropical storms. I am sure that not all tropical storms are included, but I will give them most of the historical record. Anyway, on the map of the world, there are a bunch of different color lines. The lines represent the intensity of the storm. The colors represent the intensity of the storm on the Saffir-Simpson hurricane scale. The lines originated in warm tropical waters and then followed a pathway until the storm degraded. Do you notice any patterns or anything interesting about the storm track trends? Because I like color, I am immediately drawn to the large swath of red, indicating many Category 5 typhoons over in the part of the world by Indonesia. Apparently, in comparison to the Atlantic part of things, it's not so bad. I also note the curve to the tropical storm paths. Curve to the right in the northern hemisphere and to the left in the southern hemisphere. Makes sense nicely, since we understand the Coriolis effect. In the Atlantic hurricane, tracks also track west due to trade winds. I also note where there are not tropical storms. South America is pretty tropical storm free, which has to do with the colder ocean waters on both of its coasts. You can refer to the ocean water conveyor belt if you'd like a visual of the generally cooler currents by South America. Also, I do not see tropical storms at the equator. That is because the Coriolis force is too weak, and once formed, tropical storms don't even cross the equator. I also see that once any tropical storm hits land, it degrades to a tropical storm or tropical depression and completely dissipates fairly quickly. Interestingly, as a tropical storm degrades, its forward speed increases, perhaps up to 58 miles per hour. If you notice something else cool about the storm tracks, you are totally free to let me know via email. Moving on to extratropical cyclone development in just a bit.